Our next speaker is Rafael Padilla, the co-founder of BlockDevs Asia, who will be speaking on blockchain in the energy sector, the key developments. If you have any questions for Rafael, please type them into the questions area in the live discussion section just to the right of this video, or underneath the video if you're using the mobile app. Rafael, over to you.
Good afternoon, everyone. Good afternoon. Thank you very much for inviting me here to present at the Future Energy Show Philippines 2020. I will be presenting on how blockchain and distributed ledgers are being used in the energy sector. As mentioned by Yaros, I am a co-founder and trustee of BlockDevs Asia Inc. BlockDevs Asia is an industry association of professional blockchain developers in the Philippines and beyond. I will share my screen now. And if you have any questions, feel free to raise them after the presentation. Okay, I hope you can see my screen now. So as a general purpose and foundational technology for creating a secure and decentralized and peer-to-peer applications, blockchains and other distributed ledger technologies have been compared to the internet itself in both form and also in terms of its impact. The components and the features of this technology as to how it enables decentralization and peer-to-peer application have special relevance when it comes to emerging technologies that are applied in the energy sector. The use and mainstream adoption of blockchains, smart contracts, and even tokenized assets require rethinking of the policies and the mechanisms we use to regulate individuals, companies, activities, and society with respect to commercial transactions and our social interactions. So just to level set the audience, let's give in a quick historical background on the technology. In 2008, Satoshi Nakamoto published a white paper on this cryptocurrency that is referred to as Bitcoin. The Bitcoin blockchain was eventually launched on January 3, 2009, and 11 years later, the technology has been it has been discovered that that technology can be used in a variety of applications, including applications in non-financial sectors. While the initial application is in payments, it was quickly realized that the technology that underpins Bitcoin and other cryptocurrencies can be also used in other non-financial use cases, and interestingly, including various use cases and applications in the energy industry. So what is blockchain? Originally conceived as the underlying protocol for Bitcoin, the technology has since evolved to support a number of applications, especially with the introduction of this smart contracts and how smart contracts can be run in this blockchain that is referred to as Ethereum. The Ethereum blockchain was launched in 2015. We will talk about smart contracts later, but let me just mention as early as now that the concept is not actually new. The concept of smart contracts has been discussed thoroughly as early as in the mid-90s. And the contribution of blockchain as a technology is basically how it provided the platform to actually operate in practice and realize the concept of smart contracts. Smart contracts are being applied today in various business applications. And again, relevant to our discussions in this conference, it is also being applied in various use cases in the energy sector. Some of the features of this technology, which could be useful in various applications in the energy sector includes the feature of its decentralized design. Decentralization is a key attribute of blockchains and distributed ledgers. Many replicas, this means that many replicas of the database is replicated, or many of the data are replicated in various nodes, and no one participant can tamper it. The consensus among the majority participants is needed to update this decentralized database that we refer to as the blockchain. In terms of the security layer, and this is one of the promise of the technology, blockchain uses tried and tested public and private signature technology. But blockchain applies this technology to create transactions that are impervious to fraud and establishes a shared truth. Smart contracts, again, one of the technologies enabled by blockchain. It can the technology can store Ethereum blockchain, which is a platform for smart contracts, can store both data and smart contract logic in the blockchain. And another interesting feature of blockchain is the fact that it is practically immutable. Blockchain is a write once database, so it records an immutable record of every transaction that occurs in the network. Now, the importance of the blockchain and its impact of distributed ledgers and its impact when it comes to various energy distribution architectures can be appreciated by first considering how a centralized structure operates. This is true in financial services, but it is equally true in energy sector, where you have banks and even electric distribution company in the energy sector as providing that trust in the network. Compare that with a decentralized architecture, where instead of a central intermediary validating the transactions that are happening in the ecosystem, you have instead a community of computers that validates those transactions. It seems to be inconceivable before how that can be accomplished, especially when it involves transfer of value. But since 2009, when the Bitcoin network launched, we now have a framework on how we can accomplish this architectural design. Now, blockchain, to demystify the concept of blockchain, we only need to understand, in general terms, we only need to understand blockchain within the scope of these three complementary definitions. And I would like the audience to focus their attention on the technical and the business definitions of blockchain as defined by William Mugayar in his book, 2016 book, Business Blockchain. According to William Mugayar, blockchain is a back-end database that maintains a distributed ledger openly. That's the technical definition. Another important definition of blockchain is its business aspect, which suggests that it is an exchange network for moving value between peers. Now, incidentally, the concept of blockchain also has a legal implication, such that Mugayar in his book even defined blockchain as a transaction validation mechanism that doesn't require intermediary assistance. But again, for the general audience, I think the more relevant definitions are the technical and business definition of what a blockchain is. Now, those are the key concepts, some foundations that we need to appreciate in relation to blockchain. Now, let's discuss some of the problems in the energy sector, and let's assess whether blockchain as a technology could solve this problem or address these problems. It has been observed that energy markets are top-down focused. There are few energy producers who put energy on the grid, and the grid distributes energy to consumers. Some consumers feed energy back into the grid. The concept of prosumers, which is a portmanteau of consumer and producers, no? Which I suppose in the industry is a well-known concept. If you are a prosumer and have extra capacity, you can theoretically sell it. But the problem is you have to go through a local power distributor as the trusted third party to enable that that process of being able to sell extra energy capacity. This means that the local power distributor sets the price, and unfortunately, one of the consequences of this is that the incentives for prosumers to generate surplus is limited. In some respect, this infrastructure discourages this because of the fact that these prosumers have no pricing power. But we have also observed that there are more and more people who are becoming prosumers, and energy production from prosumers are becoming more and more significant. We have also observed that energy production is getting more decentralized. Yet there is a disconnect with the centralized status quo of energy distribution, the problem that we presented earlier. So how can we solve this discrepancy or this disconnect? Maybe exploring new technologies could accomplish that. And so our discussions on how blockchain can solve some of the problems in the energy sector. What is blockchain's potential? As we've said earlier, traditionally electric utilities are centralized. Also, we have observed that electric utilities are vertically integrated. Blockchain as a technology could disrupt this convention by one, unbundling energy services along a distributed energy system. This unbundling, which is actually happening also in financial services because of technologies like blockchain, among others, other emerging technologies. We can see the same thing happen also in the energy sector. An example of this is where a customer could directly purchase excess electricity produced from their neighbor's solar panels instead of purchasing electricity from the utility. And this is no longer theoretical. We have case studies on this. We will briefly mention the Brooklyn Microgrid project, which we will discuss in the succeeding slides shortly. Another benefit of blockchain in the energy sector is how blockchain could also encourage more competition among power generators, as well as more flexibility and choice for consumers. Consumers generally, while it is true that consumers generally will not care whether blockchain is under hood or not, this is true as in, again, any other application of blockchain technology in other sectors, and the same can be said in the energy sector. But one interesting impact of blockchain in the energy sector is how it enables consumers to actually become part of a community effort. Blockchain as a technology could realize the potential of creating a decentralized infrastructure for energy distribution and even energy generation. Tokenization, which is the process of converting a physical asset, or even an intangible asset such as renewable energy certificates or even other tokenized energies, as well as gamification, which is the process of incorporating game theory and economics as a way to incentivize participants in the network. No? Blockchain as a technology could enable this tokenization and gamification, which can be powerful mechanisms to incentivize or encourage the production of reliable data at the consumer level. This means that we can now use this data in the creation of, for example, a carbon footprint balance sheet. Blockchain acts as enabler for the creation of a decentralized, democratized energy system. So we have seen blockchain so far contributing in the creation of a digitalized, decentralized, democratized energy system, and we project that this process will continue to evolve in the short to medium term. Let's focus now on decentralization, which is again one of the key features of blockchain technology. The goal of delivery and as applied in energy sector, the goal of delivering as much energy as possible at the lowest cost and with the most efficient use of renewable resources should involve bringing the source of generation as close as possible to the source of consumption. Thus the importance of decentralization. But how are we going to accomplish that? Of course, there are many technologies that could enable that, including smart meters, right, which doesn't necessarily have to incorporate blockchain technology. But focusing on blockchain technology at this point, that element, blockchain technology essentially provides the technical framework to implement these various approaches in decentralization of energy distribution and generation. Note that if communities can take charge of their own energy sources, it is possible that they can eliminate a significant amount of power loss due to long-distance transmission. Decentralized microgrids, and this is where the concept of decentralized microgrids play an important role. Okay, decentralized microgrids are less vulnerable to cyber attacks. No? This is because it is very expensive for hackers to go after multiple distributed centers of activity, as compared to taking out a single server in a centralized grid. Couple that with blockchain technology, we can expect decentralized microgrids to become more robust. And decentralized grids can also create redundancies or backups that would avert or minimize the impact of natural disasters. Decentralized approaches to grid design also allow for a much more nuanced control management of power consumption. Right? Blockchain enables the decentralized marketplace and pricing signals that the microgrid needs in order to optimize efficiency. This means that the grid's capacity can grow organically as each community member adds new revenue-earning panels and other equipment. Now, considering that the technology is still quite new, in some respects, it can be said that the technology is quite immature. There are, of course, risks associated with the technology. One of them is unbundling energy services could actually lead to concerns over distribution control. If we decentralize the architecture, it also means that we are minimizing control. So this also presents some risks. Another thing is considering the immaturity of the technology. Right? Storing vast quantities of data about critical infrastructure could also introduce new cybersecurity concerns. While we said earlier that the technology has the potential of enhancing the security of decentralized microgrids, at the same time, we have to realize that the technology could also present new cybersecurity risk, and we have to prepare for them, and we also have to take them in consideration when we are deploying blockchain-based applications, no, in the energy sector. So just very quickly, one of the important factors that has contributed to the growth of the use of blockchain in the energy industry is the formation of various technology and business consortia. We highlight here some of those consortia. One is the Energy Web Foundation, based in Zug, Switzerland, which was founded by the Rocky Mountain Institute and also by the Grid Singularity. The Energy Web Foundation, or EWF, seeks to develop an open source blockchain-based digital infrastructure for the energy sector. Energy Web focuses on building the core infrastructure and shared technology, speeding adoption of commercial solutions in the energy sector. We will discuss some of the initiatives of Energy Web Foundation in the succeeding slides. Another interesting consortia is the Blockchain for Energy, also known as the Oil and Gas Blockchain Consortium, which focuses on collaborative development of blockchain solutions. Blockchain for Energy is building a network of business partners. So the focus of the consortium is more on the business side of things, no? As compared to the Energy Web Foundation, who that is building the technical infrastructure, no, for how blockchain can be deployed in the energy sector. So briefly, these are some of the use cases for blockchain. Blockchain can be used to enable peer-to-peer energy trading. It can also be used for asset management and supply chain tracking, as well as in project financing, also in renewable energy certificates, or RECs. Energy trading systems in relation to transactional grids. Let's discuss some of them briefly. So when it comes to peer-to-peer energy markets, note that there are various multi-layered architecture. There is a multi-layered architecture consisting of various layers, such as the device, the smart meter, the transmission layer, communication, and management layer. All these layers, all the informations obtained from these various layers can be fed to a decentralized auction house, which acts as a clearinghouse of the network to allow peer-to-peer energy trading. This architecture enables prosumers to safely generate more energy than they need for themselves without the need to install large batteries, because they know that they can sell excess energy at market prices anytime. So these are some of the use cases. Smart contracts makes the use of blockchain and distributed ledger very compelling in peer-to-peer energy trading. Smart contract can be simply defined as a computer transaction protocol that automatically executes the terms of a contract. Blockchain can enable prosumers to participate in the local energy market, where they can rely on the technology, which has the potential to make transactions faster, simpler, and cheaper. Renewable energy credits, or RECs. This is another interesting area where blockchain can be applied, and in fact, it is being applied today. Imagine a future in which all renewable energy generation equipment can automatically register certificates, say in a public blockchain network, allowing them to be marketed directly to generators and also consumers. Using blockchain to trade RECs could provide customers the ability to purchase RECs without the need for a centralized entity to verify transaction. This application requires the tokenization of RECs through blockchains and smart contracts. And as an alternative to traditional platforms, this can bring greater transparency, cost reduction, efficiency improvement in the certification and trading process. So some applications right now, the French power company ENGIE has a specific use case right now. PTT in Thailand is working with the Energy Web Foundation as well to create a digital marketplace for IREX. And another interesting project is Idea Collab, which is developing a connected solar panel that generates RECs automatically while producing power in real time and registers this RECs on a blockchain. Transactional grids such as the Transactive Grid or the Brooklyn Microgrid project. This requires producers of energy resources to sell the electricity to neighboring consumers. Again, very interesting case study is the Brooklyn Microgrid project. Also, another interesting case study is in Bangladesh, where ME Solshare equips communities in rural parts with solar arrays that can generate energy and enable its trade, again, using blockchain technology. So, Energy Web Foundation, it's an open source technology stack that has 3 layers. The blockchain, which is an open source blockchain, which is the Energy Web blockchain. It is open source, but in terms of its consensus algorithm, it uses proof of authority. It also has software development kits such as the EW Origin and the EW Flex. And then on top of this layers are the application layers involving different applications of blockchain in the energy sector, such as in certificates, electronic vehicles, demand response. Yeah, to end my presentation, let me just highlight how important government support is to enable the realization of creating a decentralized infrastructure for the energy sector. We have seen in the case of Brooklyn Microgrid Project for one, how the New York City government has contributed in terms of support to realize and make the Brooklyn Microgrid experiment a success. We are seeing similar initiatives in Japan. And in fact, this has resulted in the creation of a regulatory sandbox initiated by the Ministry of the Economy because it has been observed by the ministry that P2P energy trading should be encouraged as a priority, and blockchain as a technology is a key factor that could realize that. Many of the solutions and applications in the energy sector, use case for blockchain, for example, new solutions for carbon markets, can only be realized with the support of the public sector. And with that, I end my presentation. Thank you very much. If there are any questions, I'll be happy to address them.
Thank you, Rafael, for sharing that interesting presentation. Unfortunately, we've come to the end of the presentation and we don't really have much time to answer any questions. For the attendees who are watching the presentation, you can always connect with Rafael on the Swapcard platform, just as you can connect with other attendees as well. Please do check out our exhibitors using the exhibition hold tab, and do keep up with the networking by connecting with Rafael and with other speakers using the networking tab. Rafael, thank you very much again for joining us, and please stay tuned for the next session. Perfect, thank you. Bye.
Bye.